Here's another related race problem. Let's say you have a snowball, and it's melting such that the surface area decreases at a rate of 1 square centimeter per minute. At what rate will the diameter decrease when the diameter is 10 centimeters? So let's look at what we have. We know that the surface area decreases at 1 centimeter per minute. So let's come up with some variables. Let's say A equals the surface area. And let's say D equals diameter. Sounds reasonable. Alright, so you actually know what the change in the area is for every change in your time, or every minute. So you actually know that change in the area, dA, over dt is equal to 1 centimeter squared per minute, but it actually decreases at this rate, so it's going to be negative, right? The negative symbolizes that the value is decreasing. So -1, and then you can choose to keep your units if you want, as long as you know what you're doing, you'll be fine. Minute. Yes. Okay. So what I would do you remember the area, the formula for the surface area of a sphere? Because let's assume the snowball is a sphere, or else it's going to be pretty hard. Okay, the area, surface area of a sphere, equals 4 pi r squared. Right? Now we don't actually have r in this case, we're dealing with diameter. So you might want to show the equation. 2 times the radius equals the diameter, right? So the radius equals the diameter over 2, which we can plug back into that. Area equals 4 pi, r equals diameter over 2, so plug that in, squared, and that just equals to diameter over 2 all squared is diameter squared over 4, so this will cancel. You get pi times the diameter squared, and that's equal to your area. So since you actually have the derivative of the area with respect to time, it may be useful to take the derivative, so we can plug that in. So take the derivative with respect to time on both sides. So d over dt of A equals d over dt of pi d squared. So d over dt of A is going to be just your dA over dt. And your other side, well, you can't really take the derivative with respect to time of something that doesn't have a t in it. So let's change that to derivative with respect to d, diameter, of whatever your function is, times d, that's kind of confusing, dd over dt. Yes, change in diameter, or derivative of the diameter with respect to time. Because you see how these would potentially cancel and you would still have your original function. Okay, so if we simplify that a bit and take the derivative, d over dd, I guess, of pi d squared, well, the pi is a constant, so you can take that out. The 2 comes down, right? So power rule, 2 d to the power of 1 times change in diameter over dt. And let's just make that a bit nicer, equals 2 pi d times change in diameter, derivative of the diameter with respect to time. Okay, now you actually know what your derivative of the area with respect to time is, right? You know that it's decreasing at a rate of 1 centimeter squared per minute. So yeah, you have that right there. What you're actually trying to solve for is the rate that the diameter will decrease at per unit of time. So you're actually looking for this value here. So we can actually just solve for that. dA over dt, divide both sides by this value, so over 2 pi d equals dd over dt. I don't like saying that, that is confusing. I should have picked another variable. Okay, now this value is actually given in the question, and that is -1 centimeter squared per minute. you choose if you want to keep the units. -1 over 2 pi. Now the diameter, it's asking for what the rate will be when the diameter is 10 centimeters. So that's what we're going to plug in. 10 centimeters. Well, yeah, if you don't want to keep the unit, whatever. Equals d over dt. And this is going to be -1 over 20 pi. And yes, I did it without keeping the units, so you have to go back and remember what units you were using, right? So this is a rate change in diameter over change in time, so it's probably going to be in centimeters per minute. Centimeters per minute equals that, dd over dt. Let's check if I'm right. Yes. You could also say -1 over 20 centimeters per minute means it's decreasing at 1 over 20 pi centimeters per minute. Right? Either works. The negative is just indicating that it's decreasing. So you can either say that this is the rate with the negative, or say it's decreasing at, well, the positive rate. And that's how you do this example. I hope you learned something. Thanks for listening.